video, we're going to be describing the unit circle, and then we'll be using it to evaluate some trig functions at some given angles. For the unit circle, we really just need to focus on the first quadrant here. If we can understand how the first quadrant works, we can really understand how the whole unit circle comes together. Let's start off with what are called quadrant angles. If we don't open up an angle, we have 0 degrees, which would be equivalent to 0 radians. Also, if we do a full rotation or any number of full rotations, we'll end up at the exact same spot. So we'll just focus on one full rotation, say that's 360 degrees, and its equivalent is 2 pi radians. In the unit circle, the radius of our circle is always 1. So this coordinate right here on the x-axis would be 1, 0. We went right 1 unit, but we didn't go up or down. Over here on the y-axis up at the top, we would get there by opening up an angle 90 degrees, or pi over 2 radians. The coordinate straight up for the unit circle with a radius of 1, we didn't go left or right, but we went up 1. Over here on the left side of the x-axis, I would get there by opening up an angle 180 degrees, or pi radians. And on my unit circle, if I go left 1 unit, my coordinate is -1, 0. Down at the bottom, we can get there to the bottom of the y-axis by opening up an angle 270 degrees, or 3 pi over 2 radians. And again, the coordinate there, I just go down 1, and I don't go left or right. So to start off with the unit circle, in our last lesson we were talking about how we could redefine our trig functions to be coordinates. The cosine function is going to give us an x coordinate. So if we're asked for the cosine of, say, 2 pi, we would know that that would be 1. Sine functions are redefined as being the y coordinates on our unit circle. So for example, if I wanted the sine of pi over 2, well, that would be the y coordinate, or 1. Tangent, we said, is the comparison of the y coordinate compared to the x coordinate. So for example, the tangent of pi would be 0 over -1, and we would simplify that to just be 0. So those are our quadrant angles. We're going to fill in the rest of the circle by using some different intervals here. If we split our first quadrant up in half, well, then we created a 45-degree angle right here. 45 degrees is equivalent to pi over 4 radians. If you're familiar with your 45, 45, 90 special right triangle, which we can draw right here, we can use the lengths of that right triangle to give us the coordinates of this position. So if we have a radius of 1, that means we have a hypotenuse with a length of 1. We could cut that in half and multiply by the square root of 2 to get our side lengths. So that must be the square root of 2 divided by 2. In the 45, 45, 90, our side lengths are equal. It's an isosceles right triangle. So if the x length here, or x coordinate, is square root of 2 over 2, then the y coordinate, or vertical length here, would be the exact same. So that's how we're able to get those coordinates. If I think about breaking up this half circle here into 6 equal intervals, I would take 180 degrees and divide by 6. I must be having intervals that measure 30 degrees. So we'll say that this angle right here is 30 degrees, which is equal to pi over 6 radians. So let's see how we can get these coordinates. Again, we can imagine a right triangle here with a 30-degree angle down here, which makes this a 60-degree angle up here. straight down. And that's a 30, 60, 90. So if you're familiar with your 30, 60, 90 right triangle, then you should know its properties. If the hypotenuse again is 1, half of that would be our shorter side here. So that vertical length is going to be 1/2. And if I take that short leg of my right triangle and multiply by the square root of 3, I get my longer side over here. So the square root of 3 over 2 would be my x coordinate. One last time, if I decide that I want to take my 180-degree half circle here and split it up into 3 equal intervals, 180 divided by 3 would give me 60 degrees, or pi over 3. And we can just essentially think about what we just did, but flip our coordinates, because if we draw a right triangle straight down here and say that this angle is 60 degrees, that must make this angle up here 30 degrees. So we still have a 30, 60, 90. Its side lengths just got flipped, so these coordinates are just going to get flipped. These are essentially the 3 different coordinates that are going to repeat all the way around the circle. We have 1/2, we have the square root of 3 over 2, and the square root of 2 over 2. As it turns out, this first quadrant is just going to get reflected over into the second quadrant. So notice that these coordinates here are going to be the exact same as these coordinates, except since we're in the second quadrant, our x values are going to be negative. Take a look in the middle here, exact same coordinates, except the x value is negative. And up top, we can see that they're the same, except the x coordinate is negative in the second quadrant. Going down into the third and fourth quadrant, you could just reflect the top half of this circle across the x-axis. Notice that these coordinates are the same as those, except that the y value is negative in the fourth quadrant. Or these coordinates right here are the exact same as these coordinates, except they're both negative in the third quadrant. Another way that you can describe similar coordinates here is you can just look across at opposite angles. So if I look here at 210 degrees and I trace that back over to this side, I have 30 degrees. These coordinates are the exact same, again, except for they're negative over here in the third quadrant. Over here, if I want to trace these angles over into the fourth quadrant, they're the exact same coordinates, except that in the fourth quadrant, the y value is negative. And over here in the second quadrant, the x value is negative. So that's how we can complete our unit circle as far as coordinates go. There is one last pattern that maybe you might want to use. Notice that all of the coordinates are being divided by 2. And most of the coordinates have a square root on top. In fact, we can put square roots on the top of all of them and just do a little count of 3, 2, 1, and 3, 2, 1. Simplifying the square root of 1 is just 1. All right, how do we count around the circle in radians? Well, we can think in fractions. If we start with 1/6 pi, and we just count by 6, well then up here would be 2/6, or 1/3. 3/6 would be 1/2. 4/6 would be 2/3. 5/6, and then 6/6 would be 1 whole pi there. Keep going. We got 7/6 pi, 8/6, which would be 4/3, 9/6, which would reduce to 3/2, 10/6, that reduces to 5/3, 11/6, and then finally back to the beginning, that would be 12/6, which reduces to 2 pi. Counting by intervals of 1/4. We got 1/4 here, 2/4, that's 1/2. 3/4, 4/4 is a whole, 5/4, 6/4 is 3/2, 7/4, and then 8/4 reduces to 2 pi. One last time, counting by thirds here. We got 1/3, 2/3, 3/3 would be a whole, 4/3, 5/3, and then finally 6/3 reduces down to 2. So now that we understand the unit circle and how we can fill it out, there's actually a shortcut that we can use to help us evaluate. While some people might choose to memorize the unit circle or memorize this first quadrant, there's actually a nice hand trick. Our trigonometry is in our hand. Let me show you how we can do that. If you hold your hand up, palm facing you, hopefully you can see how you can make your fingers replicate those interval angle measures. The pinky would be on the x-axis. Ring finger is going up 30 degrees. Our middle finger is going to cut it in half at 45 degrees. Index finger is going to give us our 60-degree measure. And our thumb, if we point it straight up, that'll be the y-axis there at 90 degrees. Here's our equation. Remember that all of the coordinates were being divided by 2, and we were square rooting the tops of all of them. Remember that cosine is going to be the x-coordinate, and sine is going to be the y-coordinate. So depending on what angle or reference angle we want to evaluate, we can simply put that finger down. For example, if I wanted to evaluate pi over 3 or 60 degrees, I would put my index finger down. Count the number of fingers that are to the left of that. There's 1. Let's put it in that spot. Count the number of fingers that are still up to the right of it or below it are 3, so I can put the value of 3 there. Square root of 1 is 1, so I have 1/2, and the square root of 3 over 2, those are my coordinates right there. If we want to practice this at 45 degrees, put your middle finger down. And how many fingers are to the left of it or above it? We got 2. Square root of 2 over 2. How many fingers are still up below it or to the right of it? That would also be 2, so there's our coordinates. To evaluate pi over 6 or 30 degrees, put your ring finger down. Count the number of fingers still up above it or to the left. That's 3. So we got the square root of 3 over 2 is our x value or cosine. And fingers still up to the right of that, we just have 1 of them. Square root of 1 is 1. So 1/2 would be our sine or y value. If that doesn't impress you, then maybe the fact that even our quadrant angles work will. Let's see what happens here. If we put our thumb down, how many fingers are left to the left of it? Well, there's 0. So the square root of 0 is 0. 0 divided by anything is 0. So we get our x value or cosine value there. How many fingers are up to the right of it? We got 4. Plug that in. The square root of 4 is 2, and 2 divided by 2 is 1. So we can get our quadrant angles as well. One last time, if you want to try it out, put your pinky down. Let's evaluate it at 0 or 2 pi or 0 or 360 degrees. How many fingers are left to the to the left of it or above? We got 4. So simplifying the square root of 4 over 2 again is going to give us 1. And how many fingers are up below it or to the right of it? 0. So plugging a 0 in there gives us our coordinate there. So anytime you're unsure of what your coordinates are in that first quadrant, go ahead and use your hand, and you can do a quick check to get your coordinates. All right, so let's see how that works when we do some examples here. A few things that we need to figure out as we evaluate an angle. If I want to evaluate tangent of negative 420 degrees, first of all, I need to know what I am comparing for tangent. Tangent is comparing the y-coordinate to the x-coordinate. Let's also figure out what quadrant we're in after we've rotated negative 420 degrees. So we could sketch that out. There's negative 360 plus another negative 60 will end up in the fourth quadrant. So now, all I need is my reference angle. As it turns out, if I just evaluate my reference angle, that's going to be the exact same thing as if I evaluated this whole rotational angle. It doesn't matter if I went just that much or this full rotation, I ended up in the exact same spot. So I'm allowed to use my reference angle to evaluate. Your reference angle is now going to be your best friend here. Reference angle is between the terminal side and the x-axis here. That's going to be that leftover 60 degrees, or pi over 3 radians. So if we want to use our hand trick, we can put our index finger down and find our x coordinate is 1/2, and our y coordinate is square root of 3 over 2. Check your quadrant. We're in quadrant 4, so let's make sure that y value is negative. Now we can evaluate tangent by comparing the y coordinate to the x coordinate, taking the negative square root of 3 over 2 and dividing by 1/2. Dividing fractions is the same as multiplying by its reciprocal. So let's flip that. Multiplying by 2 and dividing by 2 isn't necessary. We can cancel those, and so our final value is negative square root of 3. You can check this on your calculator. You need to make sure that your calculator is in degree mode if you're plugging a degree value into your trig function. So if you ask your calculator what the tangent of negative 420 is, it will probably give you a decimal. And that decimal should be equivalent to this decimal value right here. So ask your calculator what negative square root of 3 is, and those decimal values should match. Let's do another one over here, sine of 13 pi over 3. If we sketch it out, 2 pi is going to be a full rotation. So this would be 6/3. And then another full rotation would be 12/3. And then plus another pi over 3. That gets us to 13/3. So our reference angle is the left over there. In fact, this is the benefit of using angles in radians, because if we just ignore that numerator value, we actually see our reference angle given to us. It's pi over 3. So feel free to use that shortcut. It's always pi and the denominator. That's going to be your reference angle. So we can evaluate pi over 3. If you want to use your hand trick again, we're putting our index finger down, and that's going to tell us that our coordinates are 1/2 and the square root of 3 over 2. We're in the first quadrant, so keep those coordinates positive. And sine is asking for the y coordinate. So sine of this radian value is square root of 3 over 2. And again, you can check it on your calculator. Although this time, you make sure that your calculator is in radian mode. And then you could ask it what sine of 13 pi divided by 3 is. And it will give you a decimal value that should be equivalent to what your calculator tells you the square root of 3 divided by 2 is in decimal form. All right, if it's not given to us as a sketch already, well then we have to sketch it ourselves, because again, we're trying to figure out what quadrant we lie in. That's going to determine whether our coordinates are positive or negative. So sketching 3 pi over 2 going clockwise, because it's negative, gets us to the y-axis on top. We know our coordinates at that quadrant angle are 0, 1. Cotangent is going to be the reciprocal of tangent. So if tangent was y over x, cotangent is going to be x over y. So compare the x value to the y value, 0 over 1 is going to simplify to 0. Your calculator doesn't have a cotangent feature on it, so in this case, we got to know what we're doing by sketching it out and understanding what the cotangent ratio is. All right, part D, negative 7 pi over 4. 8 pi over 4 would be a full rotation, so we must just be pi over 4 less than that, going clockwise. Our reference angle is just going to be pi over the denominator, pi over 4. Using our finger trick if we need to, put your middle finger down, and that reminds you that the coordinates are the square root of 2 over 2, both for x and y coordinates. We're in quadrant 1, so we're going to keep those coordinates positive. Cosecant is the reciprocal of sine. So if sine is asking for the y coordinate, all we got to do is reciprocate that y coordinate, 2 over the square root of 2, and then rationalize to get that denominator out of the radical out of the denominator. Multiplying both top and bottom by the square root of 2 simplifies to 2 times the square root of 2 over 2, and we can simplify 2 divided by 2 there, and our final value is the square root of 2. Once again, our calculator doesn't have a cosecant, so we really need to rely on our understanding of what's going on here. All right, 2 more, this time in degrees. Not as easy to find the reference angle, but it's not too hard. Cosine of 150 degrees is going to be 30 degrees less than half rotation. So that 30 degrees is going to be our reference angle. Pi over 6 is equivalent in radians. So if you want to put your ring finger down on your hand, it'll remind you that your coordinates are the square root of 3 over 2 and 1/2. But we're in quadrant 2, so we make our x value negative. Cosine is asking for that x coordinate, so there's our value. This time we can check it on a calculator. Again, make sure you're in degree mode, and it should give you the decimal equivalent of this radical fraction here. Last one, secant. Secant is going to be the reciprocal of cosine. Let's sketch out this angle and see what quadrant we end up in. 8 pi over 4 is going to be 1 full rotation. So here's 8 fourths. Another full rotation would be 16 fourths. 4 fourths would be a half, so 16 plus 4 is 20 fourths. Plus an extra 1/4, we end up in quadrant 3. And pi over 4 here is going to be our reference angle. So we know those coordinates, hopefully by now, are the square root of 2 over 2, both for x and y, but because we're in quadrant 3, we make them both negative. Cosine is asking for the x coordinate. Secant is asking for the reciprocal of that. So I can just reciprocate my x coordinate here and have negative 2 over the square root of 2. Rationalize to get that radical out of the denominator. Simplify any fraction in front that can be, and we're left with negative square root of 2. All right, so plenty to digest there. Let's make sure that we're practicing evaluating these angles by sketching them out, finding their quadrant that they lie in, finding that reference angle that we can evaluate, finding the coordinates, and evaluating whatever trig function based on those coordinates. Good luck practicing. Trigonometry values are pretty popular and needed if you want to advance in math past pre-cal and get into calculus. So make sure you do that practice.